Hello guys, welcome back to another episode of Learn Smart with Faith Olasayinde, and this time we're going to be treating implicit differentiation as well as higher derivatives. Let's start with implicit differentiation. Well, most of the differentiation question we've been treating earlier is cases where y is in respect to x, right? You just have y equals to a particular function of x, isn't it? Now, what of questions where you have y and x in the same function? What of questions like x squared plus y squared equals to 5? Now, in this case, you see that we have x and y on the same side of the equation. How do you solve this? Now, the idea of this is just to use the implicit differentiation. Now, this one is still a little bit straightforward. You could just make y the subject of formula and voila, you get the answer. But there are some cases where making y the subject of formula would not even, it would be a long task to achieve and might lead to so many things like using quotient rule and all kinds of rules. But then fine, implicit differentiation is here to solve this kind of questions. Then how do we do it? Well, it is just straightforward. It is actually straightforward. All you have to do is solve it the same way you solve the normal differentiation. Now, let's differentiate x squared. Differentiating x squared with respect to x is 2x, right? Yeah. Plus, now differentiate y. But because we are differentiating y in this case, do the normal differentiation. Assuming it was x, you would have gotten 2y, right? But after you have done this, just put the y, the x after it. So for every y that you differentiate, put the y dx. Just know it as a rule. Now differentiate 5. Differentiating 5 is 0, is a constant, right? Yeah. So all you have to do now is make the y dx the subject of formula. That's all. So firstly, let's bring 2x to this side. So 2y dy dx equals minus 2x, right? Now dy dx equals to minus 2x divided by 2y. So minus x divided by y. Now, how would you see questions? Don't think you can't see questions like this in exam. I can still remember questions came very well on implicit differentiation for me in exam. But the question will be find dy dx where x equals to 1 and y equals to 2, for example. So it means that after you have done your dy dx here, all you just have to do is put x as minus 1, put y as 2, then that's the answer. So expect questions like this in the exam. Now, this is a simple implicit differentiation question. Let's try something a little more maybe complex or something more different. Now let's take for example x cubed plus x squared y plus x y squared plus y cubed equals 9. Yeah, let me just do this for example, and let me use the same style you meet in exam. Find dy dx when x equals 1 and y equals minus 1. Yeah. Okay, how do we solve this? Just like I said, just do the normal differentiation that you know, which is 3x squared, right? Plus, now in cases like this, you have to be very careful. Now, the reason is because you have two functions multiplying themselves here. I hope you remember. You have x squared, which is one function. I have y, which can be another function that we don't know, but it's just tagged y. Good. So you are using the product rule. The simple thing that I'm trying to drive at is that you're using the product rule since you have two functions multiplying themselves. So product rule. Let's quickly solve product rule for this. That's v du dx, u dv dx, and the idea of product rule is differentiate 1 write the other. Now write that one that I differentiated first, now differentiate the other. That's just the simple idea. So let's write this one, now differentiate this one. Differentiating that one is 1 dy dx, right? Differentiating y, since 1 is the power here, the 1 comes down, 1 and minus 1 from this, it becomes y raised to the power 0, and then 2 raised to the power 0 is 1, still times 1. But because remember that we said if you differentiate any y, you must put dy dx, so that's why at the end is still 1 dy dx, which is 1 dy dx here. Now plus, we have written this, we have differentiated this. Now let's write this one, now differentiate this, 2x. That's the idea of product 2, and you can quickly pen it down somewhere, solve it before putting it here, you'll still get the same answer. But that's just like a shortcut to solving product 2. So this same one, write first one, differentiate the other. Differentiating this one will be what? 2y, then dy dx. Remember that whenever you differentiate y, you always put dy dx. Good. Plus, now write this one that you differentiated earlier. Now differentiate the first one, 1. That's product 2. Now differentiate this one now, 3y squared dy dx. Now differentiate this one, is what? 0. We've differentiated everything now. I believe you understand what I've done so far. Let's now expand and 3x squared plus this one becomes x squared dy dx, right? Now this one becomes 2xy plus, now this one becomes 2xy dy dx. Now this one becomes plus y squared. Now this one becomes plus 3y squared dy dx equals 0. So all we have to do now is bring all the dy dx together, since we have so many of them. The idea is you have to what? Make dy dx a bit of formula. So let's bring everything together. Factorizing now becomes x squared dy dx plus 2xy dy dx plus 3y squared dy dx. Now let's bring all these ones together as well, equals 0. Okay, so factorizing, everything here like this goes to this side, then everything here like this is factorized. So we have x squared plus 2xy plus 3y squared dy dx equals, everything here goes to this side, that's minus 3x squared minus 2xy minus y squared. So making this one the subject of formula becomes minus 3x squared minus 2xy minus y squared divided by x squared minus 2xy plus 3y squared. So just like I said, you won't be given stuff like this in exam, but what they can do is they will give you values for x and y to make it simple. So putting the values of x and y, that's minus 3 times 1 squared minus 2 times 1 times minus 1, since this, then y is minus 1. So all you just have to do is put y and x and the values and you get your answer. This is 1 squared minus 2 1 times minus 1 plus 3 minus 1 squared. So in the end, what do you have? We have minus 3. This is not minus, this is 1. You have minus 3, then you have plus 2, then you have minus 1 all over, then you have 1, you have plus 2, then you have plus 3. So in the end, what do we have here? We have minus 2 divided by 6 minus 1 over 3. So the answer is what? Minus 1 over 3. So that's implicit differentiation. Now the idea of higher derivatives is actually very simple. For example, you have y equals to x raised to the power of 4. And you are told to find the first derivative. The first derivative of this, that's the y dx. Now the y dx equals to 4x squared, 4x cubed, right? Now what if you're told to find the second derivative? It means this first derivative, you have to differentiate again. So it means you have to differentiate this again. That's what it means. So, and in proper notation, it's always written as d squared y dx squared. That's how it's always written. Then it means it's just simply differentiate again. Differentiating again is 12x squared, right? Good. Now what of the third derivative? That's d cube y dx cube, and that's what differentiating again, that's 24x is power 1. We don't need to put 1, and so on and so forth. So that's just higher derivative. There's nothing so special about it. Yeah, I believe I've done justice to this video. Thank you very much for staying with me this far, and until I see you in the next video, peace.